Welcome. So, two basic theorems for a function continuous on a bounded closed interval. The existence of both a maximum value and a minimum value is guaranteed. The following theorem is fundamental. It's the extreme value theorem. And actually, I'm just introducing the extreme value theorem because it relates to intermediate value theorem. We're not going to be working with extreme value theorem in this lesson. We'll work with it in a much later lesson. So f is continuous on a bounded closed interval, a, b. Then on that interval, f takes on both a maximum value and a minimum value. All right, so we have three different examples here. Here's number one right here by the arrow. Yep, there we go. Come on, move arrow. All right, so here we have, and when we're referring to absolute maximums and absolute minimums. Right, so here, and here's my arrow, does not want to move. Maybe it's tired. Wants to make a box, but it doesn't want to move. Well, anyway, all right, well, we won't move you. There we go. All right, so here's our absolute minimum, right, and little m there. And then here's our absolute maximum. All right, so we have absolute maximum minimums in this case are interior points. Right? And if we have a closed interval, which starts here and ends here, every point, right, has to be represented, and then in this case we've got a value here that's below, right? It's below our actually maybe it's the same. No, that one looks like it's below, right? But you'll learn how to find this one, right? So notice that this one, we not only went from here to here, right? We went to some values below there, but you'll learn how to find those in a later lesson. Here we have a nice and easy one. Absolute max and minimum are endpoints. Right, so here's our absolute minimum and our absolute maximum. There are just endpoints there. Even if u are a constant function, you can have an absolute maximum and an absolute minimum, except your maximum and your minimum are going to be the exact same thing. So here's y equals 3. Its maximum's 3, its minimum's 3, everything's 3. Right, so from intermediate value theorem, we know that continuous functions have continuous intervals, and now just looked at what extreme value theorem is. And so continuous functions, if we have a bounded closed interval, we're going to have a minimum and a maximum on that interval. And that's basically all that's saying up there. Right, so and of course if it's constant, then both our minimum and our maximum are the exact same thing. Right, so here is our minimum. So this would be f of little m. Here we have f of big M. Big M. There we go. Right, and so using intermediate value theorem, every value between f of a and f of b must be represented. Oops, that's supposed to be a p. For a closed continuous interval. So a little introduction to extreme value theorem, but our focus isn't going to be on extreme value theorem. It's actually going to be on intermediate value theorem. All right, and so little reminder, intermediate value theorem, or IVT. If f is a continuous on the interval AB, then f takes on every value between f of a and f of b. Suppose k is any number between f of a and f of b, then there is at least one number c in AB such that f of c equals k. Right, so the intermediate value theorem tells you at least one c exists, but it does not give you a method for finding c. This theorem is an example of an existence theorem. However, Mrs. Mishagna is going to give you how to find the c. Right? I'm going to show you how to find the c, guaranteed by intermediate value theorem. So intermediate value theorem, it did the guaranteeing. I'm going to show you the finding. All right, so make sure you explain 3 questions. You're asking the questions of yourself and you're explaining them. Make sure that you state the answers or your explanations to each of these questions, right? If you are missing any part of these three questions, right, then you have not answered it, and actually you may receive no credit. On an AP test, you would receive no credit if you don't answer the very first question, which is the function continuous? You've got to ask that question and show your function is continuous. I can't stress that enough. All right, so if you say yes, your first requirement has been met. Right? Now you must show that your function is continuous. Yes isn't just enough, but maybe it was given that it is a continuous function, continuous on the interval. Right? So then you can say your function is continuous on a closed interval. Maybe it's a polynomial function or a sine or cosine, functions that we know that are continuous everywhere. Maybe it's a rational function, but rational functions are only going to have discontinuities where the denominator equals 0. So if you can show the denominator doesn't equal 0 between on your interval there, then you've shown it's continuous on the interval. Right? Maybe it's a piecewise function, right? To show that the piecewise function is continuous on the interval. Show that the two, if the breaking point is on your interval, show that the two sides are the same thing. All right. So you got to show that your function's continuous. So if you say if yes and you've shown, all right, I'm actually going to write that in here. So you have this in your notes, but I don't have this. I'm going to write this right now. And so you must state. And I'm going to put show. Actually, I'm not going to even say state. Oh, great. Now I have to figure out how to erase that. Oops. Oh, it was my pen. Without a teeny tiny eraser. That's how we'll erase that. So I'm going to write in here, show function is continuous. Very, very important. And I require that too. If you say no, then stop. Intermediate value theorem does not apply if the function is not continuous on the interval. Right? You can stay at it. So if you're asked to find the c, you can say, since the function is not continuous on the interval, intermediate value theorem does not guarantee the existence of a c. That's simple. Next, you have to you're going to ask yourself this question: is k between f of a and f of b? How are you going to find that? Well, maybe k and f of a and f of b are given to you, but if not, you're going to substitute b into the function, a into the function, and b into the function to determine. And if k is in between f of a and f of b, then you can say yes, right? And you can show your values, right? So f of a is whatever is less than or equal to k, which is whatever, and is less than or equal to f of b, which is whatever. And by the way, f of a and f of b could be switched. F of a could be the small one, or it could be f of b. If you say no, then stop. Intermediate value theorem only applies for values between f of a and f of b. Right? We don't guarantee anything else. Right? So we're on the last slide or so where we had an extreme value that was below f of a or f of b. Right? Well, we'll be solving for those using something different and not intermediate value theorem. And then finally, is c between a and b? So to find out, set f of x equal to k and solve for x. That's your c. Maybe you've got 2 c's. Maybe you've got 3 c's. You're going to eliminate any c that's not between a and b. Right? That's not your c. Right? That's just some other c. All right, so let's take a look. All right, so a little reminder there. All right, so make sure you're going to ask, is your function continuous on a, b? Is k between f of a and f of b? Right? And then you have to find the c such that that it's f of c. You have to find that c between a and b such that f of c is equal to k. Here's our little picture example. That's not what we're going to be doing. We're going to be solving over here. All right. So here's our. We do have a continuous interval, or a continuous function on a closed interval. So yes, and we have it graphed there. Function is continuous on the closed interval. Is continuous. So important to say on the closed interval because I don't know what happens after those endpoints. And in this case, I'm going to put, it's a little messy there, but C graph, but I don't have that much space to write. There we go. All right, so switch colors. Is K in between f of A and f of B? And well, you'll have values, but I'm going to put yes. And in this case, f of A is right here. And so there's f of A. And then this right here is f of B. Right, so we have f of B is less than K, is less than, I guess I should say equal, and less than f of A. All right, in this example, if C is between A and B, then there are blank C's such that f of C equals K. So if we look at our K here, how many C's do we have? We have a C right here, 1, 2, 3, but don't say 4. We only have 3, right? This one here is outside of the interval, so we're not going to consider it. All right, and so we can label them. You can be, actually I'll put them down here. You can be C1, you can be C2, and we'll squeeze you in, you can be C3. And I'll get rid of that. All right, so that's a little example just with a graph there. We're going to do kind of the same thing, only with the equation. All right, so let f of x equal x squared plus x divided by x minus 1. Verify that the intermediate value theorem applies to the interval 5 halves 4, and find the value of c guaranteed by the theorem if f of c equals 6. All right, so k is equal to 6, by the way. All right, so first of all, we have to answer our first question, right? Is the function continuous? All right, so let's take a look here. Well, where's our discontinuity, right? So it's a rational function, right? So rational functions are discontinuous, or have discontinuities, however you prefer, when the denominator equals 0, the denominator equals 0 when, oops, that's supposed to be an n, when x minus 1 equals 0, which is outside the interval. Actually, I'm going to say the closed interval. If you left off the word closed, it really would, I don't think it would make any difference. All right, so therefore, I'm going to call it f of x, not write the whole thing, since it's labeled f of x. Therefore, f of x is a continuous function. All right, we've met requirement number 1. All right, so by the way, whoops, I just hit the extended page, but I'll probably need it anyway. Continuous function. Feel free to use my words exactly and just change them, all right, so they match. All right, I have no problem with that. That's how you'll remember proper ways to note something, all right? So I don't care if you have a rational function and you write my words exactly and just change the parts that are different. I'm fine with that. All right, so number 2, right? We have to make sure that k is between f of a and f of b. And we're going to do that by finding it. And actually, I'm going to switch colors just to make it a little easier for you to see. So number 2. All right, so we've got 5 halves, right? So we have f of 5 halves. So I'm just going to label here. A is going to equal 5 halves, and b equals 4. And we just plug it in. So we have 5 halves squared. Nice little number to work with. 5 halves divided by 5 halves minus, I'm going to change 1 right away. I'm definitely going to need the extended page just because the number they gave me. I'm going to change 1 right away to 2 halves. All right, so then f of 5 halves is equal to, so that's going to be 25 fourths plus 5 halves is 10 fourths divided by 3 halves. So that means f of 5 halves is equal to, all right, so that's going to be 35 fourths. I'm going to make that times the reciprocal, so that should be times 2/3. Really hope there's no errors in here. So this would reduce, so I have 35/6. All right, and so now let's find 4's, the other numbers, the next number is a little bit nicer. So f of 4 is going to be 4 squared plus 4 divided by 4 minus 1, and that means f of 4 is 16 plus 4. If you don't mind, I'm just going to write 20, and then divided by 3, so 20/3. All right, so now is k in between. All right, so, well, 20/3, that's more than 6. And so is 35/6. 35/6 is less. Whew. 35/6 is less, because 36/6 would have to be more. Phew, we're okay. All right, so 35/6, because I was thinking 35/3. So 35/6, that's a small one. That one is less than 6, which is less than 20/3, right? So our k here is between, in this case, b and a. All right, we've met requirement number 2. All right, so now we need to meet requirement number 3 by extending this page so I have some room to write. We're going to solve, right? So we already know what the f of x is equal to. K, so at k there is your f of c, your f of x, right? So you're going to set the function equal to 6, right? So 6 equals x squared plus x divided by x minus 1. All right, so you just replace f of x there with 6. All right, so I am going to cross multiply. All right, so I've got 6 times x minus 1 equals x squared plus x, right? Because technically I'm multiplying it by 1. I'm going to distribute the x. I always try to make sure I write it down, right, with the parentheses there so I don't forget to distribute rather than doing it in my head and accidentally forgetting. So I have 6x minus 6 equals x squared plus x. To solve this, we're going to have to move everything to one side. So we're going to subtract the 6x and add 6. Subtract the 6x and add 6. So we have 0 equals x squared minus 5x plus 6. All right, so multiplies to give you 6, adds to give you negative 5. And in calculus, I'm okay if you just write down the factors, not the solutions, the factors, and then you can solve. If it's one that was tougher, then we could use factor by grouping, right? But that one's a little bit easier, isn't it? All right, so we have two solutions here, x equals 3 and x equals 2. Are they both good? All right, well, 5 halves is 2.5. So if this one isn't, no, it's outside the interval. Right, so that's not guaranteed by intermediate value theorem. But this one, that's our yes. Right? So now if that's not enough, you've got to now show what we were using here. So last time I'm going to have to write anything, so I won't have to change the page size again. All right, so now we're going to sum everything up. All right, so since f of x is a continuous function on the closed interval, I would state the interval 5 halves 4 and we got our k here. So we have, oops, I had one little error here. I put b and a. A and b are x values. I should have said f of b, k, and f of a. And f of b less than k less than f of a. As shown above. There is at least one c, or one x value. Actually, I'm going to write one value c, such that f of c equals k and c equals 3. Since we've got 5 halves is less than 3 is less than 4. And there we go. So there's all the parts. So these aren't short questions. Oh, there we go. Got a keyboard up there. These aren't short questions, all right? But they're very much formulaic questions because they'll follow a little pattern here. If your answer is yes, anyway. But do make sure you have all the parts. You have an answer this good. You'll not only get all the points on an AP test, but your calculus teacher and anybody looking at it will smile. All right, so there we have it. So f of x is a continuous function on the closed interval 5 halves 4. And since k is between f of b and f of a, as shown above, there's at least one value c such that f of c equals k, c equals 3, since that 3 there is in between our values. I may have more of them written up here, and I may erase some of them, or I may leave them. I think it's probably easier for you if I erase them. So if a group of functions has not been designated as continuous, right? So here we can't really say all rational functions are continuous, right? They're continuous if you don't have any discontinuities, if you stay away from the I should say they're continuous on an interval as long as the interval doesn't contain the vertical asymptote or whatever value it is that makes the denominator 0, the whole or whatever, right? So here we had to show that that's continuous, but some functions, we know them to be continuous, right? And so rational functions is in that group of continuous functions, right? We just have that one place where we could have a discontinuity. So if a group of functions has not been designated as continuous, then you'll have to prove continuity by showing all points that f of k, where x equals k, that f of k exists, that the limit as x approaches k of f of x exists, and the limit as x approaches k of f of x equals f of k. So you're going to have to show those three things, right, for all values of x. Doesn't come up all that often where you have to show all those things. Right? Most of the time, we're working with functions that we know to be continuous. So, but if not, you'll have to do that. Right? So, here I left it up because it's a little short. So this time we're going to use y equals f of x equals x cubed minus 3 and ask this question: will this function ever equal 0 on the interval -4, 3? So here we're using intermediate value theorem. Come on, arrow. For the existence of zeros. Right? So here k is equal to 0. Right? So number 1, we have to show we have a continuous function. Right? So our function is continuous on the interval 4, 3 because polynomial functions are continuous everywhere. Right? We don't have to prove it. Right? That is known to be continuous everywhere. All right, so step 2, we got to make sure k is in between f of a and f of b. And how we do that? We just plug it in. This one's a lot easier on the plug-in. So f of negative 4, then the last one was f of negative 4 is going to be negative 4 cubed minus 3, which would be negative 64 minus 3, or negative 67. F of 3 is going to be 3 cubed minus 3, which is 27 minus 3, which is 24. All right, so 0 is in between. All right, so since the function is continuous and 0 here is in between negative 67 and 24, according to intermediate value theorem, there is some x value such that f of x equals 0. If we set the function equal to 0, we can find out what that value is, but we actually don't have to, I don't know if that will, the whole thing will move then. We don't have to actually find c because we weren't asked to find c, which is why I didn't bother to erase this one. This one's a pretty straightforward one, right? We're just looking to make sure that there would have to be an x-intercept, right? There'd have to be a 0 between negative 4 and 3, right? And since our y values change signs between negative 4 and 3, somewhere, right, there would have to be an x-intercept. There'd have to be a 0. If we were asked to find c, let's do that part. If you were asked to find c, right, then you would just set 0 equals x cubed minus 3. And you'd add 3 to both sides, so 3 equals x cubed. And you'd take the cube root of both sides, no plus or minus because this is an odd root. And so then you'd have x equals the cube root of 3. And that is definitely in between negative 4 and 3. It's positive, and the cube root of 3 is certainly less than 3. Right? So if you were asked to find c, that would be your c. Because it is in between those values. Right, so it's that since that's true. Right? But we weren't asked to find c, so that was all we had to do. I'm going to actually stop this podcast now and pick it up with the next problem. We've got a few more problems before the end of this podcast, and we're going to be doing the same thing. We're going to be looking for c with our intermediate value theorem. All right, bye for now.